Yeah, hello everybody to our statistics course. The last time we just did a little revision about statistical parameters of a random variable, expectation value, variance, and different means. And then also we calculated some further parameters in order to describe a distribution, and this was skewness and kurtosis. And today, as a revision, we will do a short exercise, just redo our calculations with some other examples. Okay. Exercise 1. Yep. So, first, we have now a class with 17 students and the following heights. And what we shall do also for class B with 12 students, we should calculate median and arithmetic mean of A and B. Also calculate the range, the mean, absolute distance, and the unbiased, biased, variance, and uncorrected and corrected standard deviation. Well, this, since we have 17 data points and 12 data points, this I will also do with you together in Excel, but we will of course also talk about the formulas lying behind this. So I just open one. It's open. Yep. So there we are. Let's put this here that you can see everything. Okay. And this one. E1. Okay, so how do we get this data within our Excel file without typing it? Also, I think this is a competence you should have if you want to use some data you find in a PDF file in some studies. Then hopefully this is PDF is created like this, that you at least can copy these numbers. And what I'm then always try to do to open just a standard editor. And if you put the numbers within here, then you will see that there is some format of it. But what we find here then is that the format is that we have the numbers just in a row, and this hopefully, this you have always to try what it is doing. If you copy this, right click, and then you see that it is directly reading in the data in a format you can use afterwards. this is always some try and error because you do not know how the PDF was created. And but from my experience, it mostly worked when you just copy in between your data within a standard editor, because then you have a very general format. Of course, you can also try to directly copy the numbers within Excel, but sometimes then the data is distributed in a way you cannot handle it. Okay, then we take also the heights. But let's see what happens if I directly copy this. Actually, I don't know. Well, okay, this is also quite good. Then you have just to take the data from here and put it beside the other one. Okay, so this was then class A. Oh, this was A. And then let's take also B. Copy and paste. Height and H. So then what we shall do is to calculate the numbers. This one and take here also this data. And class B. So the first one was arithmetic mean and median of class A and B. What we will do then at first for the median, what we are doing in order to find the median of these distributions. Yep. Yes, from the lowest to the highest or the other way around, of course. And this you can do here. Oh, you don't see this. Then we have to move this downwards. So, and you also have to see what I'm clicking on here. This one. Okay. So then go to data and then you can sort it and by height and increasing. So while the numbers doesn't really matter, but now we have here the data sorted from the lowest to the highest. Well, we can also put this in here. Then you see also the last data point. Okay, we do the same with these numbers. Data, sort, and H. Well, and then we know this is, here we have 17. Where do we have to look for the median? Or we can also write here just 1, 2, 17 is this plus 1. And here we had 12. Yep. Yes. So this is the median, because then we have 8 data points below and 8 heights which are longer than 178. And what it is with the class B, where we have the parameter for the age, what do we have to do here? Yep. Yes, it's 6 and 7. And what we have to do then, so since these two numbers are differing, it's 27 and 28. So what is the median then? Yeah, 27.5. Yeah, because then we just have the arrangement that we take the arithmetic mean of these two numbers. So median is then equals 0.5 times 27 plus 28. Oh, 0.5. Come on. So then the arithmetic mean. What do we have to do then? Well, we can directly use the formula, or we just sum everything up equals sum and dividing by the number of our data points. Dividing by 17. So let's put this here. So this would be then the arithmetic mean. Again, the same thing as here. This would be then sum of all our numbers for the age divided by 12. And this would be then the arithmetic mean is 28. And there, of course, you see again that these two numbers differ a little bit. So what else? And we could directly take this for A. Would be then A for class 8, A, and for class B. Oh, sorry. This was B, and let's put this one equals 178. This is then for A. So especially this one would be sum I equals 1 to n xi and 1 over n. So calculate the range. B for A, well, this is not that hard. There we can just see the largest guy minus the smallest guy. And this is the range. Is 199 minus 165, and here we have the range as 45 minus 19. So R equals 199 minus 165 was 43, and B was 45 minus 19 equals 26. So then we want to have the mean average distance. What do we have to do then for A? So not just giving me the formula, but if you really have to do it. This I want you to do in this exercise. What do we need for this? Mean average distance. So MAD was defined as 1 over n sum xi minus x bar absolute value I from 1 to n. What do we have to do then with our first data point 156 in order to get the numbers where we at the end get the aggregated number of mean average distance? Yep. Yes, of course. So we have to calculate 165 minus this 176.7 and so on. And since we in the end have to sum up everything, and we do not want that numbers below and numbers higher than the average cancels out, we have to take the absolute value. So this would be then abs is the formula for this of 156 minus 170, and we want then to copy this formula because we do not want to always type in this formula for every 17 data points. And this, then we can do it by hand and with a pencil. And for this, we have to fix this number here. And this is done by inserting a dollar sign in front of the D and the 14. Because then when we copy this, you see it, and I click in here, then you still see that this is not moving downwards. It's only the B4, B5, B6, and so on is moving downwards. And then we can downward copy this formula here. And what do we have to do? Well, we have to sum up all our distance and dividing by 17 in our case. So MAD would be then equals the sum of all these numbers divided by our total number of data points, 17. And of course, this we want to do also with our second one. So here, since we already have this formula, we can just copy this formula here. But now you see that, of course, this is calculated with respect to the average of the other one. So where do we find now the average of our second sample? This is the 28 here. Therefore, we have to change D14 with, what is it, I9. And you see already here, then this becomes red, and you know where your formula takes the data from. Okay, now we can copy this downward, and the mean average distance is then again the sum of these numbers divided by 12. So mean average distance for A this would be A, and B we have 483. So biased and unbiased variance. If we have already our mean average distance, what can we use then from our formula? What do we need for the variance? If we go back in the definition, variance was just, where is it? Range here. So what we in general need is the squared distance from the average. So if we have already calculated the mean average distance, we could just square this one. This would be all right. Or you take this formula, copy it here, and then we do not take the absolute value, but the squared number. And fortunately, this is the same number. And then again, we can copy this downward. And let's move this a little bit up. And then first we should calculate the biased, I think. Unbiased and biased. So unbiased variance is then the sum of these numbers divided by unbiased means 17 minus 1, n minus 1. And this up here, the biased variance, and for this we just can use the same formula, put it here, and we skip the minus 1 here. And what else? Uncorrected and corrected. So the corrected one is standard deviation. This is just the square root of the unbiased variance. So equals square root of the unbiased variance, and the uncorrected variance is just the square root of our biased variance. Well, and all this we have also to do for the for our other sample. Let's move this here downward a little bit. This is not enough, almost. Let's put it down here. And we also need the square of the distances. So this one squared, moving downward. And then we just copy all this here. And let's see what we have to change. So this is almost right, but we have to start at 3. And you see this? Yeah. So we have to start here, not at number 1, as you see it here in the formula, not I1, but I3 down to I14. I3 to I14. And of course, we need the 12 here. So this is then F14. Yeah, and then we take this formula here, down here, and skipping the minus 1. And here we directly see this, everything has copied in the right way, because this was just referring to the biased and unbiased variance. Okay, so then let's copy this for A and also for B. So this is just an example. I know this is not really hard to do it, but I think, or when you think that you have not only 17, but 50, 100, 200 data points, please just start to manipulate the data by your own. And maybe also think of not only using some statistical software and directly feed in the data, pressing enter, and there is coming some data out, but that you should know what you are doing. So then number B. Something I'm always a friend of, because you're studying economics, and well, in the first shot we always just calculate arithmetic means if we want to calculate any average, but sometimes this is not the appropriate number which we should calculate. And for this, we just have a look at two possibilities to invest. So one investment is maybe some stock. So it's going up one time and going down the other time. So plus a yield of plus 10% in the first year, second year minus 15, plus 12, plus 7%. And then we can also talk about an investment without volatility. So some savings contract should, for the last 4 years, yield an investment of from 1,200 euros. In the end, you should have 1,350 euros. And now we should compare these two investments via their yield, so to speak, which one would be better. What would you do then? Let's do this also in Excel. Take another thing. This is E1, and let's take here E2. Which investment has the higher yield? And this has something to do with averaging. And I think you have already heard some lecture on financing and investment. I think these examples you should have also seen in your introductory course in mathematics or in statistics. It should be not that new. So at first, I want to calculate a per annum yield for this savings contract. Within 4 years, I'm investing 1,200, and after 4 years, I have 1,350. What is then the interest paying per annum, per year? Any idea? So let's take here the savings contract. So we are starting with 1,200, and then after 4 years, 1, 3, 2, 3, 4, oops, plus 1, this one. We are ending up here with 1,350. What's the information of, let's say, the stocks? After 1 year, I think we had 10, 15, 12, and plus 7. 0.1, 0.15, no, minus, or minus, and then 12 and 7. 0.07. We can also format this, that we have the percentage. So at which investment or at which number would we end if we also invest in the stocks 1,200? What do I have to do then? Yep. Mm-hmm. Okay, so you just calculated from this information the amount you get, and how did you do it? Yes, great. So in the first year, we have 1,200. So this is equal to 1,200 times this plus, oops, plus 1. So this is then the growth factor, because still we have our 1,200. 10% is 120. So if I press enter now here, we should see a 1,320. And then we are going down by 15%. This is the same formula, going down from 1,320 down with 15%. We are at 1,122, and then again going up by 12% and going up by 17%, and you were right. So from this calculation, then we see that our savings contract, we obtain 1,350, and here we obtain an amount of 1,344. Well, but in general, when we are talking about investments, then we are not only always want to calculate these absolute numbers, but in general, we just say, well, for this investment, on average, you obtain, I don't know, 3%, and for the other one, maybe 4%. So again, statistics is also about we want to generally compare things. So we want to calculate general numbers, and what we here want to calculate is the general average year yield per year. And what do we have to do for this? Yeah. Okay, and how did you do it? Yes, great. Definitely. This is totally right. So, for the savings contract, what is the thought experiment behind it? Well, we have 1,200 euros at the starting investment. And then we say 4 years with the same interest rate, we end up with 1,350 euros. So this then means 1 plus I times 1 plus I times 1 plus I times 1 plus I equals 1,350, and we are interested in this interest rate, which is constant over time. Well, and this then means nothing else than 1,350 over 1,200 equals 1 plus I to the power of 4. And in order to obtain the interest rate, we have done the fourth root of 1,350. 200 equals 1 plus I, so fourth root of 350 over 1,200 minus 1 equals I. And this I will then calculate here. Average yield equals 1,350 over 1,200 to the power of 1 over 4 minus 1. And this is then 2.9884% equals, you have the same number? 884, yeah, okay, percent. Well, and for our stocks, we have the development of 1,200 times 1 plus 10% times 1 plus minus 15% times 1 plus 12% times 1 plus 7%, and this was roughly 1,344. But now keep in mind these two numbers here. We actually don't need for the calculation of the average yield. We have here now 4 different numbers. And so what we have to do now is to calculate the geometric mean of these numbers, because what we want to have is now a number, an interest rate, which is constant over time, which means that we also come from 1,200 to 1,344. So the task here is 1,200 times 1 plus, I call it now I bar for an average interest rate in the first year. And now we are not differing for the second year, but again, the same one, I bar plus I bar plus I bar, oh, 4 times, sorry. I have to write it a little bit in another way. So, up plus I bar 1 plus I bar 1 plus I bar equals. And then you see this calculation is independent from the first investment and the number which is coming out. Because then we just have to calculate 1 plus I bar to the power of 4 is 1 plus 10% times 1 plus minus 15% times 1 plus 12% times 1 plus 7%. And what we have to do then is just to take the fourth root again now of these 4 growth factors or interest factors. So then I bar equals, and this I will fetch now here. Is this possible? Yep. This didn't work. Okay. Then back again. So then group this. No, this is grouped already. Good. So this I have to group. Yep. And now I can move it down here. Pen 1 plus 7. Oh ja. Yep. Wie mache ich das? Mach's mal gerade so. Ne, this is not working. And no, not all. Again. And now it should work. Almost. Yep. No. This one. Now you see it. Let's see, then I just put this one. Okay, and what we have done here is just that we have calculated here the geometric mean of the yield factors. So let's calculate these also, that we have the number. So for this we need the yield factors, so 1 plus the yield in every year. This is not that nice if we take this in percentage. So let's change this to normal numbers. And then calculating the geometric mean. This would be the fourth root of it, or product, the same as sum, to the power of 1 over 4. Oops. What did I do wrong here? 1 to a7. Oh, the brackets are missing. So this would be then hopefully the same number. Yes. Okay. So, and minus 1, of course, is then the average yield. This minus 1. And for this, we can again take the number here. Is it surprising that this number is lower than this number? Or not? Would you expect that this number here, the yield of the stocks, is lower than the yield, average yield of our savings investment? Yep. Yes. So it has to be. So if this number would be higher than this number, there has to be something wrong. Maybe you have miscalculated something here, but if this number is lower than this number, then this number has to be lower than this number. This has to be the case. So then we have here that this is 2.8853%. Oh, now my Zoom meeting was because the internet. But you told me on Friday you had also internet problems? Okay, I'm sorry. So back again. Oh, if you see somebody who is answering something in the chat, then please give me a hint because I have no eyes in my bag. So do you see and hear me again? in the internet? Hello? Yes? Okay. So your colleagues told me that also on Friday our university had internet problems, so I had just no connection to the internet. Okay, so we have to write down here our number 2.8853%. 2.8853%. Well, and I think why I created this example is, the reason is, if I take just the average here, so the arithmetic mean, what do I obtain? I obtain 4%. So this is the arithmetic mean. And if you would just calculate the arithmetic mean of these yield numbers per year, then you would say, well, it's great. The stock investment is much better than the savings investment. Well, the reason why we have here a large discrepancy is we have here yield factor yields around 10% and more, and even the downturn is very large by 15. And this really moves the right average downward below the yield per year of our savings account. So let's write this also down here. Be careful, because the average mean is 1 over 4, 10% minus 15% plus 12% plus 7% equals 4%. But this is, in this case, just not the right mean which we have to calculate. But this is not the right mean. And all this is statistics about, that you always know what you are doing. So 11:30, then let's take this one. So consider we have two firms, A and B, issuing new capital in the medium term with the following market capitalization, PI, and net income, EI. PI at firm A should be 200 billion euros, and the net income should be 8 billion. Also for PB, 800 million and 4 million. So then we say that we want to create something, an index for maybe some portfolio investment or something like this. And For this, I don't know if you have talked about this in other lectures. We quite often calculate the so-called price earnings ratio, P over E here in our case, just the market capitalization divided by the net income. And then we would say that we want to calculate an index where the weight of both firms should be the same. So a weight with 50% of firm A and firm B. What would be then the index number? Well, let's calculate the price earnings ratio for both firms. PA over EA is 200 billion euros over 8 billion euros, and PB over EB is 800 million euros over 4 million euros. Let's take this also in our Excel sheet. E3. So A, we have P and E. You see this here, and P over E. This was 200 billion euros and 8 billion euros. And P over E is then over 8. And for B, we had 804. But we have million euros. So this earnings ratio is then 200. Well, the average, the arithmetic mean would be then just 0.5 times 25 plus 200, 112.5. So this was 25 and this is 200. Would be 1/2 times 25 plus 200, and this is 112.5. So, would this be a reasonable number for these two firms? Yeah. Yes, and because we have here this drastical difference that the one firm is much, much larger than the other one. So, and for this, then the reasonable, or maybe you can also say right, averaging process in this case would then be, remember this this example when we are driving with 100 kilometers to Oldenburg and coming back with only 50 kilometers per hour to Wilhelmshaven. Then also we know that when we are driving 100 kilometers per hour, then we are much faster than, so in time, we take less time than when we drive only 50 kilometers. And then we had to take the harmonic mean, and here we have also to weight in the right direction, that this firm is much larger, and therefore we have to take in this case, or a reasonable averaging process in this case would be that we take the harmonic mean in order to get an index. So, but firm A is much larger than firm B, and therefore the reasonable averaging process in this case is taking the harmonic mean. And how did we calculate it? The harmonic mean. So the index would be then 1 over 2 to the power of minus 1 plus 1 over PA over EA plus 1 over PB over EB. And this also to minus 1. And let's try this. After my file has been saving. So we need the inverted number here equals 1 over 25. This also 1 over 25, and then the harmonic mean is then 0.5 to minus 1, or just 2, of course, but that you are not puzzled, times this plus this, and also to minus 1. Hopefully I didn't mistyped anything. And then we get 4.4. And then you see, of course, your index is moving much more in the direction of this larger company. As it should be. If you have an investment with one really large company and one small company, then the average should be in the neighborhood of your large partner. So this is then 44, which is much more in the neighborhood of firm of the large firm A, like it should be. Well, of course, you are definitely allowed to just calculate the index via the arithmetic mean. But we should think of, is this then a reasonable number? And in this case, when we want to calculate something like an index, then we have also to keep in mind that we have different sizes of our firms, and this should also be in our averaging process. So these were then two examples from economics where we have to use, or where we should use, other averages than the arithmetic mean. Okay, then thank you very much for today.